In this video, we are discussing about Jfet. Jfet means junction field effect transistor. So, symbol for Jfet. Jfet is of two types, N channel and P channel. So, if the channel between S and D, source and drain terminals, is N type, then it is N channel. Likewise, gate will be of P type material. Likewise, here the channel between source and drain is P material, then it is P channel. So gate will be of N type. And now the symbols are indicated as source, drain and gate. It will be analyzed with water flow from the tap. Gate controls the flow of water from source to the drain. So likewise, voltage applied between the gate and source will control the flow of electrons or passage of current. Now let's see the different types of FET. Two types of FET are there: junction FET, MOSFET, metal oxide semiconductor. Okay, then it is still classified as depletion mode and MOSFET as depletion mode, enhancement mode. Based on the procedures used, it will be classified in that pattern. Okay, procedures of fabrications will be differing for depletion mode as well as enhancement mode. Under depletion mode for Jfet, N channel, P channel, which already I explained. So these are the symbols used here. And then under MOSFET for depletion mode, again P channel, N channel, symbols used here. For enhancement mode, N channel, P channel. Now let's go on to the next one, the working operation of Jfet. We have 4 cases. Let's see one by one. Case 1, once we take that into circuit, VGS and VDD need to have some biasing. So we generally go VGS as a reverse bias and VD will be given forward bias. And once the voltage is not applied at VGS and VDD, VGS is 0, VDD is 0. So oh, the junction will be formed near the PN. P and N layers, a junction is formed, or we call it as depletion layer here. So the two terminal portions of gate is combined together and taken as one lead, mentioned as gate. Here comes the drain, here comes the source. So the channel is indicated here. This is the channel which we were discussing. Initially no voltage is applied, then a small junction formation will be seen here. And now if we give 0 volt and we make this source to gate as reverse bias, then apply VGS, that becomes the next case. So when VGS is given negative voltage, small Ig current will be there, it is reverse bias, no flow will be there because no flow of current will be there because the connection is not yet connected. IDS will be 0. When we go for the third case, VGS is 0, VDD is applied. There comes the current flow. We can see how the electrons will be flowing. It is the flow of electrons seen here. And now we go for the third case where we see more VGS is applied and the depletion layer will be growing in this way. So once the VGS is still increased to more negative, then we see the depletion layer is trying to close the channel. So this voltage which we observe is called as pinch off voltage. And now if we analyze this, between drain to source there results a resistance divider. That is the VDS applied is 2 volt, which is divided as the resistance which we are seeing here will be analyzed between drain to source. So near the drain the voltage drop is 1.5 and still decreased here as 1 and still it decreased to 0.5. So near the source the voltage will be 0.5 drop. So only the depletion layer near the source is less, whereas near the drain it is trying to close the block, close or block the passage of electrons here. Now let's move on to types of characteristics. Types of characteristics. We draw graph between current and voltage parameters. So we know that in the circuit the parameters take an input side and it is input parameter, output side output parameters. So the transfer input characteristics which indicates one parameter from input side, one parameter from output side. VGS is input side and ID is output side in the circuit. So only it is called as transfer input characteristics. Then comes drain characteristics. In drain characteristics, two parameters are taken at output side only. So only it is called as output characteristics. Now Scotlay's current equation is defined for FET as ID will be equal to IDSS or within bracket 1 minus VGS by VGS of means where the pinch off occurs, which will be taken as VP here. So once we take VP, substitute the values, and then VP gets cancelled. We have two cases of VGS equal to 0, VGS equal to VP. When VGS equal to 0, we have ID equal to IDSS. When VGS equal to VP, at saturation, VP gets cancelled, and then IDSS will be equal to 0. 1 minus 1 will be equal to 0 now. So let's see the graphs of it. This is the transfer characteristics. When VGS is VP, we have ID equal to 0. When VGS is maximum, we have maximum IDSS value. When VGS is 0, ID will be equal to IDSS in this formula. Okay, now let's move on to drain characteristics. So this is the drain characteristics. We see three regions here. This is the ohmic region, saturation region, and the breakdown region. Okay, now in the ohmic region, the relation between current and voltage will be linear. So it follows the Ohm's law. That is, variation in current and voltage will be in linear form. So only it is called as ohmic region. Once the values cross the green line, dotted green line here, the area is called as saturation region in the graph. So this graph is drawn between ID as well as VDS here. So both the parameters are output parameters here. Now once putting VGS constant 0 and making it still negative, the curve is moving towards the x-axis here, and likewise the current will be IDS will be constant here, ID will be equal to IDSS over here. Whatever change, it will be change in voltage, but the current in circuit will be same, constant. And now after that, if we still increase the VDS values, it enters into breakdown region, which is not a desired operation of FET. The device will get damaged here. This region is called as breakdown region. That is, small change in voltage leads to huge current here. Small change in voltage leads to huge current. And now let's see the Jfet parameters. These are the four parameters. Drain resistance. Resistance means voltage by current, so it is called as drain resistance. Putting VGS constant. Then drain conductance, GD. Okay, and now it is 1 by RT. So VGS is made constant. Then drain conductance. Drain conductance means we know that conductance is taken as transfer conductance ID by VGS. So the parameters are output parameter and input parameter here. so transconductance. Similarly, we have mu amplification factor, which is ratio between output voltage and input voltage. VDS is output voltage, VGS is input voltage in the circuit. Now let's see the difference between FET and BJT. First of all, FET will be having low voltage gain and high current. And here, then apart from that, we have very high input impedance in FET. In BJT, low input impedance. Then high output impedance here. So only it is used in many circuits. There is a proper isolation between input and output terminals in Jfet. Whereas here BJT is not having any isolation between input and output terminal. So there lies noise. So the next difference is low noise, as I told you now. Here medium noise. And then switching time in transistor we have discussed in the class, it is very high, whereas here FET is having fast switching time, and FET easily gets damaged by static electric field, but transistor is robust along it. And then to start the FET or to change the FET, it needs some gate voltage here, whereas BJT doesn't need any gate voltage. So this FET is voltage control device, BJT is current control device. FET exhibits some properties of resistance. BJT you don't have such option, and FET is expensive, whereas BJT is cheaper. And then more expensive that we discussed just now. So it is difficult to bias the FET. It is very easy to bias the BJT. Then isolation of input and output, already I have mentioned. Now let's see the applications of it. FET will be used in many circuits like oscilloscopes, voltmeters, measuring devices where we need high input impedance. Then it will be used in RF amplifiers for FM devices, and then FET voltage control device. So based on that voltage variable resistor in op amp. And then we have FET in intermodulation, that is in communications and all, we'll be using that. These are the few applications where we see FET. Since the switching speed is high, we'll be mainly using in the digital circuits also, where 1 to 0 to 0 to 1 switching is required. So this is about FET. Thank you. So repeat this video, learn the concept clearly, and prepare for the exam well. Thank you.